Hey guys, welcome to another video. Now this is our final little pit stop of content before we finally get towards the idea of factorizing a variety of different quadratic expressions. Now what we're looking at today is this idea of factorizing by grouping in pairs. And what this is going to do is it's going to build up on everything we've learned about factorization, both regular factorization as well as binomial factorization. And we're going to take those two ideas and look at factorizing these really big expressions. Now what we're going to do here is we're going to split these four terms up into a pair of two algebraic expressions. So what we're going to do is I'm going to take this one, for example, this one, and this one here. So I'm effectively breaking this expression up into two pairs. So we have pair one and pair two. I'm going to factorize these separately. And we're going to see if we can do anything more to simplify this and factorize it fully. And this is going to form the building blocks for the next few videos. Okay, so let's think about pair one first. So pair one is x squared plus 2x. Now, is there anything we can do to factorize this? Well, I can think of one thing. The only thing we can do is we can see there's an x in both of these terms. So we can pull it out as a common factor. So we're going to have x here. And like we've been doing with all of our other factorizations, we want to see what multiplies by x to give me x squared and what multiplies by x to give me 2x. So what multiplies by x to give me x squared? Well, that's just going to be x. And to get to 2x from x, I'm going to multiply that by positive 2. So that's my first factorization for my pair 1. Now let's take a look at pair 2. I have 3x plus 6 plus 6. And what I want to do now is I want to find a common factor. I want to factorize again. So we need to think what number goes into both 3x and 6. Well, the most obvious one I can think of would be 3, because that goes into 3x definitely, and it also goes into 6. Now it goes into 3x x times, and it goes into 6 positive 2 times. Now what I'm going to do, now that these have been factorized individually, I'm going to rewrite my expression, my initial expression here, but just in the different form here, in the factorized form, this initial factorized form. So I have x outside of x plus 2 plus 3 outside of x plus 2. Now, this is no different to this thing here. There's just a couple of things factorized. I've taken the x out of this pair of terms. I've taken the 3 out of this pair of terms. Now that I have this, do we notice anything familiar? Well, this to me looks like a binomial factorization, because we have this same expression, x plus 2, in both of these terms. I've condensed the pairs into two bracketed terms, two factorized forms with the same bracket. So now what we can do, we can use our binomial factorization. So what does that mean? Well, going back to what we did in the previous, well, 2 videos ago when we talked about binomial factorization, we are going to pull out our common factor x plus 2. So we're going to pull this out here, and I'm going to see what was multiplied by x plus 2 to give me x outside of x plus 2, this first term, as well as 3 outside of x plus 2. Now, just for a little reminder, how these are written is a shorthand for a multiplication. Remember, anytime we write a number next to brackets, a multiplication is implied. Excuse me. Now, in my first term, I can see that x has been multiplied by x plus 2 in order to give me x outside of x plus 2. That's fairly straightforward. And the same thing happens for my other term, 3x, 3 outside of x plus 2. So when this is fully factorized, this looks like so. So we have provided a full factorization of this long expression here. We have condensed this into a binomial factorization, a binomial product, because these are multiplying here. Think way back to the start of this video series. Now, I'm going to do the same thing that I've been doing this whole time. You don't want to just take my word for it. We want to check and make sure this is correct. So I'm going to check this by using the FOIL method. So I'm going to multiply each of these terms together. They're all going to interact. So when I multiply x by x, I get x squared. When I multiply x by 3, I get 3x. When I multiply 2 by x, I get 2x. And when I multiply 2 by 3, I get 6. So that is what we had up the top. Now, I can rearrange these two. It doesn't really matter. I can rearrange the positioning of them, but it is the same term. In the same way that 2 plus 3 is the same as 3 plus 2. The order when we add doesn't matter. So this is the same as what we had up here. So we have factorized correctly. Now let's try one more example, and then we'll move on to one final harder one at the end. But what we're going to do here is we want to factorize x squared plus 3x minus 5x minus 15. That's going to go here. And I want to group this in pairs. So I'm going to say, all right, well, let me make one pair here and one pair here. Now, I'm going to pull out a common factor in each. I'm going to do these separately. Now, to save time, I'm not going to really break it down in the same way as the first example. I'll just do the next line of working. So from this term up here, this pair, my first pair, x squared plus 3x, I can see that x is a common factor. So I'm going to pull that out front here. So I have x outside of, and to factorize this, I'm going to go through it a little quicker because we've done this a lot. I'm going to have x outside of x plus 3. Okay, now in my next term, I want to factorize this. Okay, so I can see that negative 5 goes into both of these terms. Positive 5 goes into it as well, or negative 5. I'm just going to pick negative 5 because I personally find that easier to factorize because I have a double negative. So for me, it's going to be easy to pull out the negative. And I'll show you in a second why the sign is going to matter. But I'm going to pull out negative 5 here. And I want to see what goes into both negative 5x and negative 15. So minus 5, what does it multiply by to give me minus 5x? Well, it multiplies by x. And what does negative 5 multiply to give me negative 15? Positive 3. Now that we get here, you can see that, well, once again, we have this binomial factor that goes into both parts of this expression. So I'm going to pull that out as a common factor. And when I pull that out, my first expression here, what multiplies by x plus 3 to give me x outside of x plus 3? Well, that's just going to be x. And what multiplies by x plus 3 to give me negative 5 outside of x plus 3? I have negative 5. So I have factorized this completely. And just for a bit of work for you to do at home, I'll get you to have a go and check this on your own if you'd like. Now, I want to bring up a point here. Now, what if, for example, because the main thing that we want here is we want these two expressions, these binomial expressions, in order to factorize these effectively, we need those to be the same. But there is a case that I could have done this in a different way and actually gotten a different answer where I couldn't proceed. So this is going to simulate this section of the video, how I'm doing this, how you could go about fixing this up if you hit a roadblock. So remember I said that I could pull out either negative 5 from both of these terms or positive 5 as a factor. Both of those would work if I wanted to factorize negative 5x minus 15. So let's say I pulled out positive 5. How would that change what is inside my brackets? Well, instead of having x here in the brackets, how many times does 5 go positive? How many times does positive 5 go into negative 5x? It goes negative x times. How much does positive 5 go into negative 15? It goes into it negative 3 times. Now you can see here, I'm at a standstill because these are not the same. These are not the same binomial expression, or I should say factor. That's a problem because we need these to be identical in order to make our binomial factor, to use the binomial factorization we know from before. So what I'm going to do instead is I can see I have two negatives here. So that tells me that positive 5 is not the factor I wanted to pull out. But if I change this to a negative, then that will change the signs of my things in the brackets. So my x will become positive and my 3 will become positive. So now these are the same factor and I can proceed with factorizing it like I normally would. So there's going to be a little bit of mathematical manipulation that we're going to do around the brackets, just because we need this to be the same as this in order to proceed to get it to the most factorized, simplest form. Now, I'm going to do one more example in this video. This is going to be to factorize 2x squared minus 9 minus 18x plus x. Now, this is where I'm going to show you this and I'm going to deliberately make a mistake to show you that the order matters for how we do these things. So sometimes we may need to rearrange our terms. Now, in the two previous examples, the order worked really nicely where I could just group the first two terms, then group the next two terms. I did the same thing up here. I grouped the first two terms into a pair and the next two into a pair. I'm going to do that as well for this example, and I'm going to see how far that gets me. So I'm going to say, all right, and remember, this is me deliberately making the mistake. and I'm going to try to factorize these. Now, here, I can't actually factorize this first term. There are no whole number factors that go into 2x squared and negative 9. I can do it for the next one, this second one. I can go, all right, well, I can say that's like saying x outside of minus 18 plus 1. I can factorize that there, but that doesn't really do anything for me. So the order in which I choose my pairs is going to matter. So what I'm going to do is, if the first pairs I've selected don't work, I've got to then try another set of pairs. So what I'm going to do is I'm going to say, well, okay, I have 2x squared here. That's going to be really easy to factorize with this x over here. So I'm going to try to group those together. So I'm going to rearrange the order. So I'm going to say 2x squared plus x minus 9 minus 18x. So all I've done here is I have rearranged the order. Okay, so I've rearranged the order to give me this. Now I'm going to try to group another set of pairs. Now I'm going to try this one and this one. I'm going to see if that gets me a bit further. Because remember, in the end, we want this thing to look like this form down the bottom here, with a binomial factor in each, the same binomial factor in each. So I need to keep rearranging and finding different combinations until I get something that looks roughly like that. So with my pairs now, in my first one here, I'm going to take out a common factor of x. So x goes into both of these. And how many times does x go into 2x squared? Well, it goes 2x times, because x times 2x gives me 2x squared. How many times does x go into x? Well, 1 time. And okay, now I want to factorize my next pair. Now, you can hopefully see here that I can have minus 9 going into minus 9 as well as minus 18x. So I'm going to pull that out as a common factor. Okay. How many times does negative 9 go into negative 9? Well, that goes 1 time. How many times does negative 9 go into negative 18x? It goes positive 2. Oh, sorry. Yeah, sorry. It goes positive 2x times. So here you probably could have seen that negative thing coming up, same as up here. So I could have picked, for example, 9, but that would have given me negatives in the bracket, which would have been different to this one here. So I want to choose negative 9 as a factor to give me my positive 1 plus 2x in here. Now you could be asking, oh, well, this thing is different to this. Now it looks slightly different, but not really. The expression is still the same. The order is just different, right? We have 2x plus 1 over here, and we have 1 plus 2x here. Now for addition, even though we don't know what 2x is, when we add it to 1, no matter which way we do it, it still gives us the same thing. In the same way that, for example, 3 plus 1 is the same as 1 plus 3. The order of addition doesn't really matter. So whether I write this as 2x plus 1 or 1 plus 2x, it's going to mean the same thing. So just for the sake of not confusing myself, I'm going to rewrite this, and I'm just going to swap the order of the 2x and the 1 in my second bracket. So now I can see that these pretty clearly look like I have a binomial factor in each of these terms. So the next thing finally to do is I'm going to pull out my binomial factor of 2x plus 1, and I just want to fill in my remaining brackets after I factorize this out. Now I want to see how many times does 2x plus 1 go into x outside of 2x plus 1? Or in other words, what do I need to multiply 2x plus 1 by in order to give me x outside of 2x plus 1? Well, I'm going to be multiplying by x here. Remember, we have these little multiplications implied. And finally, I want to see what did I have to multiply 2x plus 1 by in order to give me -9 outside of 2x plus 1. Now that thing there is going to be -9 being multiplied here. So now I have factorized this fully. Now, let me just check. I'll do the check here with you guys just to see that we've done this correctly. So expanding this using my FOIL method, I'm going to multiply 2x by x to give me x squared. I'm going to multiply 2x by -9 to give me -18x. I'm going to multiply 1 by x to give me positive x, and 1 by -9 to give me -9. And you can see here what I get at the end is the exact same as this thing up here, just in a different order. But remember, with adding and subtracting, the order doesn't matter. We're going to get the same result. So in other words, this thing here is the exact same as this thing down here. But that is how we can factorize these bigger expressions with 4 terms via the technique we know of grouping in pairs. And this is going to lay the foundation for all of the quadratic factorization we're going to be doing in future videos. Thank you so much for watching. I'll see you there.